everybody, welcome to my talk, A Decade of GPUImage. I am Janie Larson, and if you want to follow me on Twitter, my Twitter handle is RedQueenCoder. So, I'm not sure how many people here are actually familiar with GPUImage or not, but GPUImage is a hardware-accelerated video and image processing framework that is an open source project that's been around for like about a decade. The first iteration of GPUImage was at one point the third most popular Objective-C repository on GitHub. The functionality of GPUImage is similar to like Snapchat or Instagram, where you're able to pull in images and live video from your camera on either an iOS or a Mac device, and you can apply filters to it to give it different effects and to do different things with it. And one of the things that this allows you to take a bunch of different filters that exist within the framework and be able to chain them together to create your own unique effects that aren't necessarily included within the framework. So a lot of people that I've talked to who do open source, they haven't really spent a decade working on one framework. Like they'll do a framework that'll fix something that they need, and then Apple will Sherlock it, it'll get deprecated, like they won't update it after like Swift 2.1, and so it doesn't work anymore. And so like a lot of people that I talk to don't really have the experience and opportunity to work on a project that needs to be maintained and refreshed every couple of years that has been around for a decade. So I wanted to kind of take this talk and give a case study from the perspective of what it was like to go in and actually have a framework that a lot of other people use that has been around for as long as it has. So the overview of the talk is, well, okay, so I'm going to go over kind of the prehistory of GPUImage, about how it came about, why it was developed, and kind of the background behind GPUImage. Then I'll go over the actual initial iteration of GPUImage framework. I'll talk a little bit about some of the issues and complications that we encountered by using the Objective-C programming language. I will talk, okay, why the heck is, come on, sorry. Next, I will talk about the second iteration of GPUImage 2, the Swift quoll. We went in and rewrote GPUImage in Swift when that became available because it solved a lot of the problems that we had maintaining this long-term project. And the last iteration of GPUImage is GPUImage 3, Metal with a Vengeance. So I'll talk a little bit about how we needed to go in and create a third version of GPUImage because of changes that Apple implemented at WWDC last year. I'm going to talk a little bit about the future of the framework, like how we're going to continue to maintain it, what's going on with it, like where we're at right now with GPUImage 3. And then finally, I'll give you some tips for your own open source projects if you want to go in and have a project that you maintain for a long period of time. So this is kind of the prehistory of GPUImage. GPUImage was initially conceptualized in its prototypical form, or the alpha or beta, or however you want to call it, back in 2010. So this very handsome man up here on the screen is my husband. And for those who don't know, his name is Brad Larson. Brad is a moderator on Stack Overflow. He created one of the first 500 iOS apps that shipped on the initial App Store. It was a molecular modeling application that Apple used to demonstrate the features of the iPad in the Apple stores. He's done lots of really incredible stuff and is a really smart and talented guy. So back in 2009, OpenGL ES was announced. OpenGL ES was a way of being able to use OpenGL shaders and being able to write image and graphics processing stuff for mobile devices. Apple supported that in 2009, but then in 2010, they did a session on the programmable shaders, but also created some APIs that would allow you to capture live video feed from your phone and be able to run it through OpenGL shaders. So Brad was sitting at lunch with a guy named Dave Kinney, and he was talking about like, man, this looks like really awesome. I would totally like love to see somebody actually implement this where you could actually pull in these videos and like have live filtering of them. And Dave was just kind of like, well, you're a smart guy. I think that you can do it. I'm running this conference, second conf in like 3 months. I'm gonna make you like the headliner guy. I'm gonna tell everybody that you're gonna go and do this, and you got 3 months to figure it out, and I have faith in you. Go. And so he was just like, oh, God damn it. So he spent like months digging through, dumpster diving through all of Apple's documentation, spent a bunch of time trying to figure out like how all of these different APIs worked, how to get all the shaders working, and he was able to cobble together this really cool like demonstration that he demonstrated at SecondConf in 2010. And for years afterward, like people kept coming up to, like kept contacting him and saying like, dude, like I need that sample code that you presented at SecondConf. Like I need to do something like that. I need to know what you did. I need the sample code. So he, like after years of having people ask him for the sample code, he was just kind of like, okay, you know what? Like I should just make this into an actual project. And I should open source it because I'm tired of all these people constantly asking me for this code, and I can just point them to this directory and say, here, if you want the code, here it is. So the original GPUImage was released in 2012. And the original GPUImage was kind of, it isn't what it is now. It had like one shader, it had one thing that it was able to do, it was just able to like filter live video, and there really wasn't a lot of stuff to it. So like, everyone was like, okay, that's really cool that you like put this out here and did this, but I need something that does X, or I need something that does Y, or I need I need all of these filters, and so like over the course of a couple of years, Brad went in and kept adding new features to the framework. So like when he originally conceptualized GPUImage, like GPUImage wasn't a thing yet. It was only available on the Mac. Eventually it came to iOS. It was, I think GPUImage originally wasn't hardware accelerated, and it eventually became more optimized and efficient, and it began to have a lot of the functionality that GPUImage had, but like initially starting out, it didn't have that. So like some of the advantages that existed with GPUImage over GPUImage was like it allowed you to write your own filters. It used the OpenGL shading language and not some weird kernel language that existed on Apple stuff before. It was optimized enough to be able to run live video on the iPhone 3GS, and if I looked at my slides before the Stump the Experts thing, I would have remembered that. And then, like again, it was completely open source and customizable. With one disadvantage of GPUImage is that even though it has all of these different filters, you can't see how they're actually like written. And the instance of some of the filters that in GPUImage, like there's different implementations of it under the hood based on what piece of hardware you're running on, but you can't see that. That's all abstracted away. You can't look at any of this, and you can't go in and like learn from the GPUImage filters because all of the code is abstracted away. So he spent 2 years going in, adding filters, adding functionality, and doing a bunch of other stuff, but there were some things about Objective-C that started to really like bug him and started to cause like not problems, but like just there were little like missing stair things where you just kind of jump over the missing stair, but like it was just kind of like there's got to be a better way of doing some of this. And one of the things that was kind of a pain in the butt with Objective-C was dealing with header files. And like, yeah, I know this is kind of a given that we all kind of remember that this was the thing we used to have to do with Objective-C, and it was kind of a pain, but like, for every single file that we had, you had to have 2 files. And when you have over 170 different types of shaders, that adds up like a lot, and most of the code was redundant, so like you weren't having unique code in all of the different files. So if you changed something one place, you had to change it in multiple different places, and you had to maintain all of this code, and a lot of it was redundant. So like this really added a lot of overhead and a lot of like bulk to the framework that was really not necessary. Another limitation of the original GPUImage was that shader code had to be created inline. So iOS didn't support frameworks until 2009, and everything had to be built to a static library. And so like the way that this was implemented so they would be able to work on like older versions of iOS and like and have backward compatibility, you couldn't create this as a framework. You had to build it as a static library, and the OpenGL shaders are not built at compile time, they're built at runtime. So it was really hard to be able to create a static library of code that it had to build at runtime. So like if you look at this really carefully, these aren't shaders, these are strings. So like all of this shader code is basically a giant multi-string literal that was written in Objective-C that had to be built to a static library in order to be able to be shipped as a framework and put on GitHub. And this was a real pain in the butt. You couldn't go in and like get any syntax highlighting. You didn't get any warning that any of your shaders were broken until you ran your code and it crashed. And then you'd have to kind of go and like try to like figure out how to get everything to work. All the tooling that existed then was really primitive, especially for GPU programming. So going in and trying to figure out what was wrong with the shaders was really difficult to do in the original GPUImage. And again, mentioned there was no framework support. All the stuff had to be static libraries. You can't include it in a bundle. You had to use all of these C macros, and this was just kind of a limitation that was difficult to deal with. Additionally, you had to use you had to double your shader code, because, so I mentioned that that in like 2009, the Kronos company came out with OpenGL ES. They'd had OpenGL around since the 80s, but OpenGL was a completely like different framework than OpenGL ES. OpenGL ES was kind of an optimized version of OpenGL, and it had a more limited set of commands in it than the original OpenGL did, but the Mac needed OpenGL and the iPhone needed OpenGL ES. And the only difference between either of these code is if you look at the properties, the one on the bottom has precision qualifiers. I think it's the one on the, nope, it's the one on the top has precision qualifiers. So you have this varying high P vec2 instead of varying vec2 texture coordinate. Like just that one word meant that you had to write all of this code twice. And so again, this was like another thing that was really difficult to deal with like OpenGL and with Objective-C, was having to write all of this code twice, having it in these strings, and like just having this redundancy that was really not necessary. Another part of Objective-C that we really didn't like was having to deal with a bunch of subclassing and not being able to have protocol-oriented programming. So the way that the framework was originally organized was that you had like a superclass for like image input, and then you had a subclass of that was like image output, and then you had all of these different like input filter subclasses, and you had to put a whole bunch of code in all these little input filter subclasses in order to get them to work with whatever type of shader needed that particular type of input. So you might have a function inside of there that only applied to one filter out of 50 that was using this superclass. So you had these really big bloated classes that had lots of stuff in them that you didn't necessarily need, and that had like multiple levels of subclassing because because everything could only inherit from one thing. And again, these are all complaints that we've had about object-oriented programming, but I thought it would be useful to remind everybody about how bad things used to be. So then in 2014, Swift was announced by WWDC. And it was not by, it was at WWDC. That was around the time that I met Brad, and Brad hired me to come and work at his company as the programmer working on his robotics software. So his robotics software was written originally in C++, then it was rewritten in Objective-C because Objective-C was a lot better to deal with than C++, but there were still a lot of problems that he had dealing with his Objective-C code base. Things would go to nil, which like is fine if you are dealing with a phone that can crash, but if you're dealing with a $10,000 piece of hardware, going to nil is really bad. So like I was supposed to come in and like write unit tests and fix bugs and patching and whatever, and the whole time we were talking, he kept saying, well, this would be so much easier if we could just do it in Swift. So after a couple of weeks of worrying that I was going to get fired because I wasn't getting anything done, I said, well, why don't we just rewrite it in Swift then? So he was like, hey, you know, that's an interesting idea. So we spent a year going through and rewriting his robotics software in Swift. And that was kind of like a prototype that we had of working on a big project in Swift for the first time, because we had known requirements, we had a legacy code base to look at, we had functionality that needed to be replicated, and that gave us a chance, that gave him a chance to go in, try a bunch of different stuff, rewrite his code, figure out that he could like eliminate redundancies, and have a software architecture project to see what he could do to optimize all of his code. After we finished that project, I left working for him to go work for Black Pixel, mostly because I decided that I'd rather have him as a boyfriend than as a boss. And that eventually worked out well, but I wouldn't recommend that as a career path for most people. So our original rewrite of the software was completed in 2015, and he was able to take all of those lessons and put out GPUImage 2 in 2016. And one of the things that was really exciting between when Swift was announced in 2016 was that they announced that it was now open source and that it would work cross-platform with Linux. So one of the decisions that was made in 2016 was to continue with the OpenGL part of the code base and just rewrite everything in Swift so that it would continue to work cross-platform between Mac, iOS, and Linux. So he saw a huge difference between the code bases. The code base shrank to 22%, not by 22%, to 22%. And again, it worked on both Linux as well as iOS and Mac. It was significantly easier to extend and test, and it had a more understandable internal architecture. I mentioned back in 2012 when he originally released the framework, he had no idea what features people actually wanted. And so you kind of build onto something, and when you don't go into something with a plan, your architecture doesn't necessarily reflect things the way that you want it to. So when he went in and rewrote this code, he had a set of requirements, he knew everything that it needed to do, and he knew what types of problems he had to solve before he architected all of the solutions. So this allowed him to make the framework more extendable and readable because he knew what people were actually going to need from the framework. So one of the big wins that we got from rewriting the software in Swift was taking advantage of protocol-oriented programming. Like I mentioned before, that we had these gigantic, bloated superclasses that had a bunch of stuff in it that we didn't need for every single instance of the subclass. By going in and being able to create these protocols and protocol extensions, we were able to take all of these different pieces of functionality, break them down into little tiny bits, and be able to apply them to only the things that needed to be able to implement them. Another big win was being able to use standalone functions and not have to include everything in a class. So we were able to create functions that looked like this, that could go in and could take in a bunch of different parameters. It could return a tuple, and it could do error handling. And we didn't have to include this in a class. It had to be subclassed by a bunch of different stuff. We could just create this as its own function and be able to access it from anywhere in the application. A big problem that both of us had with Objective-C in both of this project and the robotics project was the fact that in Objective-C you could only return one thing. And with Swift, they allowed you to create tuples and be able to return multiple things from a function. And again, they were able to do that with error handling, because with error handling in Objective-C, you had to do weird function pointer stuff, and sometimes if you look at the error, your code would crash and become corrupted. And so being able to implement better error handling, be able to have optionals, tuples, and be able to have these standalone functions really made a huge difference in our ability to be able to implement the code in less code than before. Thank you. So by being able to use protocol-oriented programming, we were able to, anytime we did have to use a class, we could make them incredibly simple. We could just create a bunch of small classes throughout the application. So this is one of the classes associated with one of our image operations. I believe in the original Objective-C code base, this class was I think 30 or 40 lines long, and this is only 6. So we were able to not only cut down on these gigantic superclasses, but we were also able to take all of the individual subclasses of the image filters and make them much smaller. Another win for readability was the ability to use custom operators. So in the original Objective-C, if you wanted to create a chain of different filter operations, you had to go in and have several lines of boilerplate code of setting up the filter operation, setting up its input, setting up its output, and then connecting the output to the input of the next filter. By going in and creating this custom -- caret operator, you could put all of that on the same line of code, and it was a lot easier to understand that input feeds into operation, feeds into output. So this allowed you to put all of this stuff on one line. It got rid of a lot of boilerplate code, and it looks a lot more readable, where if you're coming in and you're just looking at this like, oh, okay, I grok how this kind of connects to one another. We're also able to really take advantage of using custom types. So in graphics processing, there are a couple of different things that use like collections of 4 float variables. That could be color, that could be position in 3D space, and you don't really have a way of knowing which one it is, because everything is just like a GL int 4 float whatever thing. So you'd have this 4 float property that could be put in different places, and you didn't know if it was a color or if it was a position. By being able to go in and create these lightweight structures in Swift, you're able to give them like a name, so it was clear that you're dealing with a color and not a position. You could implement safety protocols to make sure that you weren't putting a color into a position, and that you could go in and actually like convert things from these 4 float variables that were colors to whatever the weird abstract OpenGL instances were. So that way, like, you didn't have to deal with the OpenGL, you didn't have to like look at it, you could kind of encapsulate it in this nice friendly Swift code that was a lot easier to read. And another big win was we finally were able to take advantage of syntax highlighting. We didn't have to go in and create all of these weird, like, multi-string literals with all of the code. We were able to go in and actually create like OpenGL files. There's still a script in there that converts everything to a static library, because Linux doesn't really like have the concept of frameworks the way that iOS does. But we were able to like get rid of all of these multi-string literals and be able to have actual like shader code that could be highlighted and debugged by the compiler. I probably said that wrong, and I'm going to get yelled at later, but it'll be all right. So just kind of like an overview of like the code reductions. We're able to get rid of the header files. We were able to eliminate this deep class hierarchy and get rid of all of these inherited methods. Define custom lightweight types, take advantage of function overloading, and use custom operators. And again, like another advantage, these are all the advantages of just using Swift. There was also the additional advantage of being able to go in and have another bite at the apple of being able to say, okay, I did this wrong because I didn't know I was going to have to implement these things, or I over-architected this part because I thought I was going to need more abstraction than I actually did. So we were able to actually like take advantage of going in and learning from our mistakes by being able to go in and re-architect the application. But this would not have been possible if we'd just done it in Objective-C. It might have been a little bit smaller, but we would not have seen the safety and reduction that we got from moving over to Swift. So let's fast forward to last year. Last year, OpenGL was deprecated. And like I'd been waiting for OpenGL to get deprecated for 4 years. As soon as I saw Metal announced, which was the second biggest announcement of 2014, I was like really looking forward to OpenGL being deprecated, because I thought if I went in and spent like 4 years learning Metal, that like I would have this like awesome niche skill set, and people would come to me and want me to do contracting work, and I was all gung-ho about OpenGL being deprecated. But I wrote a book on Metal, and like, okay, I'm gonna be the Metal expert, and this is gonna be my thing. I'm gonna position myself in the market to be this person. So I went to Brad and said to him like, hey, I need a project to work on with Metal so that I can like learn it well enough that I can get people like pay me to do it. So can I take over GPUImage? He's like, well, we have to update it for Metal because now that it's deprecated, it's not going to work on Mac and iOS. We're still going to keep GPUImage too because we want it to work on Linux, but we'll just kind of like fork the framework so that we have an OpenGL version and a Metal version. So we're all gung-ho about this. We were going to get it done by the end of 2018. It was going to be a big thing. I announced it. Everything was going to be great. Well, then stuff happened. So last year, Brad and I got married, which we were very happy about, but like, even though the wedding wasn't very big, it was still very, very stressful. And we kept talking about, okay, well, you know what, like the wedding will be over soon. We're getting married at the beginning of September. After the wedding's over, then we'll have free time and we'll be able to work on other stuff. Well, then Brad kept tripping over all of my piles and piles of cookbooks and all of my stuff in the house. We realized the house was a little bit too small, and then we had to go and sell the house and buy a new house, and we had to move. And I don't know if anybody's moved, but moving is horrible. It was like, it was so awful, it was so stressful. We had to like both move out of our old house, sell it, and then move into the new house all in the same day. And like my in-laws came the day before, and we thought we'd packed everything, but we'd only packed like 2/3 of our stuff, so they were there for 14 hours helping us pack all of our stuff, so we didn't get any sleep. So they were like, okay, all right. So that was at the end of December. I was like, all right, okay, cool. New Year's, we'll be in the new house, and we'll have time to go and work on our stuff. Well, then Brad got the opportunity to apply at Google to work on the Swift for TensorFlow team with Chris Latner. And I don't know if anybody has gone through the Google hiring process. I don't know how much I'm allowed to say, but needless to say, it was incredibly stressful. So we had a couple of months of just studying for the interview, going through the process, and that took up a lot of our energy. And that brought us to about a month ago when we were like, oh crap, WWDC 2019 has come and gone, and we still do not have this project done. So Brad, getting ready to go to Google, kind of said to me, hey, I'm kind of done with this. I've been doing this for 10 years. This was the thing that I did during my free time and my off hours when I was working on this robotics software, and I couldn't work on all. His primary interest in all of this was he was interested in machine vision and object detection and all of the AI possibilities associated with analyzing live video. I was a graphic designer before I went into programming. To me, I find all of the math of the filtering and the artistic possibilities of this to be the most interesting part of the framework. So he's kind of hey, I got to do what I wanted to out of this. I am going and working on all of the object detection stuff full time. I'm done with this. So I was like, okay, I guess that means that I am now responsible for the metal version of GPUImage. So this is now my thing, and I'm kind of intimidated because he's really smart and figured out all of the stuff, and now I have to follow in his footsteps and not drop the football, and that's a little intimidating. But there were a few things that we were able to take advantage of to make the transition less intimidating. So we're using the exact same API between GPUImage 2 and GPUImage 3. Our goal was to have it where when we get GPUImage 3 completely function complete, that all you have to do when you use GPUImage 3 is you just change the import header from GPUImage 2 to GPUImage 3, and everything should still work exactly the same. You shouldn't have to change anything. Here's an example of the difference between the gamma adjustment operation in GPUImage 2 and GPUImage 3. All of the code's almost exactly the same. The initialization is just a little bit different, but this is abstracted away from the user, and the user isn't going to need to understand that any of this is different. So we've had some kind of challenges and opportunities associated with metal. So one of the advantages of being able to do this is that in GPUImage 2, the shader code was still inlined as a string. So we still had to support the static framework stuff and deal with the Linux side of things, which was kind of a pain to do. It wasn't too bad, but it was still pretty bad. By having it be just metal, we're able to go in and take advantage of the fact that we can just bundle this as a framework. So I mentioned that the OpenGL shaders were checked at runtime. Metal shaders are checked at build time, which means that you can use the compiler to go in and actually tell you if your code is not working properly before you go and build things. And there's not the possibility of shipping broken shaders the way that there was with the original GPUImage that used OpenGL. One big advantage in the whole aspect of trying to conserve code is that you have the same shader code for both Mac and iOS. There's no metal and metal ES. There's just metal. Metal is the same framework between Mac and iOS, so you don't have to have this double shader code. You can just have the code be there once. One really big thing that we were super happy about is they have much better debugging tools, and finally this year they support Metal on the simulator, so you don't have to build it to device, which we've been waiting for a couple of years. Apple is a lot more invested in Metal because it's like their thing that they designed to work with their hardware and their stuff. So like they're supporting it in a way that they didn't support OpenGL. So like every year that they've introduced Metal, like I keep expecting the number of WWDC videos about Metal to go down. Because it's like, okay, like I find this to be really cool, but like most people aren't going to use this if you're not working on a gaming engine. So like eventually one of these years they're not going to have like as many videos about Metal. But like every year they keep introducing more videos about Metal. They add more functionality and they add better tools to make it easier for us to go in and figure out what's going on the GPU. So that's great for me, but I don't know how it goes with other people. Again, now runs on the simulator, new for 2019. Probably should have read ahead on that, but all right. And the last thing that was really, second to last thing that was a really big advantage of Metal over OpenGL was that it supports multi-threaded operations. So with OpenGL, you had to use like a dispatch queue and lock down the context because you could only have one thread touching the context at a time. So like even though you could really highly optimize the concurrency for OpenGL, you couldn't run multiple operations all at the same time. With Metal, you're able to go in and you can create a lot of different threads or warps and be able to perform like thousands of operations all at the same time, which was a really big advantage over OpenGL. And the last bit that was really significant about Metal was the Metal performance shaders. So I mentioned earlier that under the hood, like Apple will create shaders that like will perform differently on different types of hardware. So they went in and created a bunch of shaders for primarily like image processing and like scientific computing stuff that were they have multiple iterations of the same implementation that runs differently on different hardware depending on where it's going to be optimized. So you get Gaussian blurs, you get a lot of different things that you don't have to go and like figure out how to implement in your own code and write shaders for that are common with like machine vision and like image processing. So a couple of different lessons we learned from Metal. So like good Swift abstractions allow for stuff to be swapped out easily. So like we were able to go in and basically like copy all of the Swift code and paste it directly into the Metal GPUImage framework because it was all basically the same. One of the challenges was that a lot of the shaders had a property called a uniform, and there's a lot of code associated with OpenGL that made it easier to work with the uniforms and to pack them. But like Metal was architected entirely differently. Instead of creating these uniforms, you have to take all of your properties and you have to pack them into buffers and then like pass the buffers back and forth between the CPU and the GPU. So like it's a little bit of a different architecture, and there's a little bit more work associated with it. One of the things included in Metal is this Metal render pipeline reflection API that you can use to get the name of the uniforms, but like again, this isn't something a lot of people need to use unless you're building your own game engine. Like I'm not saying to not build your own game engine, but like I've been told that it's not a good idea. And then like going in and importing the shaders from GLSL, the Metal shading language, like most of the code is very similar because both languages are about describing mathematical operations. So like there's only so many ways that you can describe like a vector, or describe a square root, or describe whatever. So like most of the syntax between GLSL and Metal is fairly similar. So it's been fairly easy to be able to go in and port all of these OpenGL shaders over to Metal. And again, like before in the original couple of OpenGLs, we had to make the data structures thread safe because it could crash the application if more than one thread touched the OpenGL context, and that's not a thing that you have to worry about anymore going forward with Metal. So there was a little bit of Metal, but like not that much. I hope I didn't frighten anybody away. So last, I wanted to give just a little bit of advice to you if you're thinking about going and creating an open source project that you'd like to last for the next 10 years. So one big thing is to make example applications. With the original GPUImage, which we still have a few things we need to port, but I think there's like 10 different example applications, and those serve a couple of different purposes. One is it gives the person who's using your framework a good starting point for how to do common things. So like if you wanted to go in and know how to process live video, we have an example application that just has like a pass-through filter with all of the boilerplate code in place where you can basically just copy and paste that or use that as like a basis of an application and be able to work with doing whatever you'd like. The other advantage of doing that is that you go in and you run all of your example applications every time you update the framework, and if one of them crashes, then you know you did something wrong. Think about how to structure your code to be easily used by other people. So like I did a talk yesterday about being on the autism spectrum, and I mentioned that I'd worked at like 20 different companies, and people at every company like have like shorthand stuff that they develop for themselves where they assume that everybody kind of has the same background and experience that they do, and they would do things exactly the same way that they would because they don't have a lot of exposure to how other people work with their code. So like it's really easy when you're making something for yourself to just kind of go in and do what makes sense to you, but like think about like, okay, if I'm not me, if I'm somebody on the other side of the world who doesn't know me, doesn't know anything, like what would I need to do in order to make this readable and usable by somebody who does not have the same background and experience that I do? Maintaining is less fun than building. Building is a lot of fun because you're doing all this new stuff and everything's really great and awesome, and you reach a point where you feel like everything is done, and then Apple goes and changes stuff and you have to go and fix it, and then all of these annoying people come to you with bug reports about how your thing is crashing, and you're not getting paid for any of this, and you have other things that you would like to be working on. So like if you're going in and you're getting ready to work on a project that is going to be used by big companies that are going to be dependent upon the work that you're doing, go in knowing that there are going to be days when you do not want to work with this, where you want to be done with it, but that you have an obligation to continue to maintain it because you made that commitment when you put it out there in the world. Which brings to the whole like idea of like, well, if it's open source, then people are going to contribute. People will contribute to your project, but they'll do so out of need. They'll go in and they will fix bugs only if it's crashing their code and they need this to get fixed. They're not going to like randomly come in like they do on Stack Overflow and go, okay, what can I fix today? It's like, oh crap, this thing is broken. I need to get it working in order to be able to ship it to the App Store. What the heck is wrong with it? Okay, cool. I'm going to go and I'm going to fix this. And then alternately, there will be times when people will contribute bug fixes, but the bug fixes only work in their specific instance, and they will break other parts of your code. So you have to go in and like look it over, make sure that it works with everything, and maintain what's going on. Also, know when to sunset your project. Matt Thompson recently did a Twitter thread where he talked about a bunch of his projects that he'd open sourced that had gotten to a point where like they weren't really needed anymore. They didn't fulfill a need in the market anymore. So like at some point, whatever you're doing is probably not going to be needed anymore because like Apple will take care of it, or it just won't be a thing that is necessary anymore. So like just kind of go into it knowing that like you're fixing a problem right now in like a new API, new framework or whatever, but probably at some point somebody's going to go in and take care of the thing that you did, and just be okay with that. Be okay with like, okay, people were able to use my project for the last 2 years because Apple wasn't doing it. Some like a better solution has come along, or we don't need to do this anymore. I feel good about the fact that I helped people for this number of years. It's time to retire this and move on to something else. And the very last thing that I want to say is that you have no idea what is going to be popular. So one reason I went on the long spiel at the beginning of the talk about the founding of GPUImage was that Brad didn't realize this was going to be a big thing. Like, he kind of thought that this was like neat from a machine vision standpoint, but this was before Instagram and before Snapchat and before all of these other things had come out and taken advantage of this stuff. It's like the guy who invented the internet who said he was surprised by cat videos. Like, when you create something, you don't have any idea what's going to be popular. So you might spend a year putting together an open source framework that you think is going to be awesome, that everybody's going to fall over themselves to use because it solves a problem that you have but nobody else has. So there isn't anything wrong with going and putting together a framework that people aren't going to use. Just kind of know that don't take it personally if you put a bunch of work into something and nobody uses it. And do different stuff. If your first thing that you do doesn't really take off, do something else and just keep throwing spaghetti at the wall until something sticks, because you don't really know going in what's going to stick and what isn't. Don't get discouraged. Go out, build awesome stuff, and do the best that you can. Thank you.